We are given if the length of the diagonal of a square is m minus n. We are now asked to find the area of the square. So let us start by drawing the square. Okay, you have a square. And you have the diagonal. So you know here is 90 degrees. They say the length of the diagonal is m minus n. I know this is a square, all the sides are equal, so let's call the sides x. So there are also x. So we have, as you can see, we have a right angle triangle, maybe ABC. So we know that from this is 90 and this is an isosceles triangle. So if here should be 45 degrees, because we know the diagonal of any square bisects the vertex angle. You know this is also 45. So from our 490 triangle theory, the value of the diagonal, that is, I'm saying that m minus n must be x times root 2. But there is a theorem that states that if you are given a right angle triangle, that the angles are 45, 90, that if here is x, the length, the longest side is x root 2. So that's how we got that. So we are looking for, remember, the area, and area is x squared. So first of all, let's get x first. So x is m minus n over root 2. Therefore, the area is always x squared. So which is m minus n over root 2 all squared. So which is m minus n all squared over root 2 squared is 2. So I think there is nothing like this. Okay, let's expand this. This is m squared minus 2mn plus n squared over 2. So okay, let's continue. We can divide each of these because they have this common denominator, so which is now m squared over 2 minus this over this is mn plus n, this over this, n squared over 2. So our answer is B. Given the area of a rhombus is 35 cm square, if the diagonals are this and this, we have to find the value of x. Okay, from what we've known before, that area of any rhombus is always half times the diagonals. Diagonal 1 times diagonal 2. That's the formula. And they told us that the area is 35, so we have 35 equals half. One of the diagonal is x plus 2, while the other one is x plus 5. Okay, we are forming an equation here, so we have 70. That's 2 times 35. We are left with x plus 2, x plus 5. So we expand this. This is x squared plus 2x plus 5x is 7x plus 10. So finally we have x squared plus 7x minus, that's 10 minus 70 is minus 6 equal to 0. So this is a quadratic equation. So let's factor this. This is x plus 12 and x minus 5. So if you open this, you get back this. So as you can see, for the product of two numbers to be 0, either the first is 0 and the second, so which implies that x is minus 12 or 5. So but there is a little problem. We cannot use minus 12, because if you put minus 12 here, minus 12 plus 2 is minus 10. Why this is so? We have a negative diagonal, which is not possible. And also here, if you put minus 12, we also have a negative diagonal, so the only answer is just 5. So our answer is option B. So we're asked to find the length of a side of a rhombus if the lengths of the diagonals are root 10 and root 5. There is one formula I derived before in my previous video. That's the introduction of this topic. We can relate the side of a rhombus and its diagonal. So any side of a rhombus, so any side, okay, let me use x. So x being the side of the rhombus is always d1 squared d2 squared all in square root over 2, where d1 d2 are the diagonals and x is the side. So this is a very important formula, so we apply it. X is now d1 is root 10, so anyone could be root 10 or root 15 squared plus root 15 squared all in square root over 2, so which is 10 plus 15 all in square root over 2, which is 25 over, that's square root 25 over 2. So our answer is 5 over 2. So you don't need to waste time. Yeah, so that's the relationship. I derived it earlier.